So today we're going to be talking about peppers, and that's something that's always been kind of interesting. It's probably one of the oldest traditional medicines in the Western world, at least. It's been around for quite a while. I can, well, not when I say that, actually, the hot red peppers are not old compared to some of the things in Europe, I guess, but it's certainly an older one compared among the Native Americans in that, because the red peppers actually originated in North America. Now, the black pepper, the Sichuan peppers, and those kind of things are really a whole different species of plant. Well, not species, but a whole different category of plants. They're not the same kind of peppers at all. But these originated in the North America, probably in South America, I think, and were hybridized by those old cultures that it's kind of surprising that they had the technology to do that. But it's been a traditional medicine for a long time, probably partly because of its pungency. The kind of the Victorian era idea is that something tasted bad, it had to be good for you. If it was hot and painful, it's probably good for you. And something that gave pleasure and stuff under their way of thinking, was probably decadent and not good for you. But I think we've abandoned that for the most part. But that kind of still idea carries on. But peppers do have some good benefits to them. And it's kind of interesting to compare the hot peppers versus not hot peppers and how they affect you. It turns out that here in the Carolinas, we have the hottest peppers in the world, really. If you look at the top on the left here, that top pepper, right below pepper spray, the Carolina Reaper has 2,200,000 Scoville heat units. That's a hot pepper, say the least. You really, a friend of mine grows those actually, and they cut up, put tiny amounts in pepper jellies and stuff like that. I mean, tiny amounts. When they cut the peppers up, they wear masks and gloves and protective clothing, literally put a fan blowing away from them. And still they, get, still hard to do. I mean, these things are just really wild peppers. In fact, probably at least one person is believed to have died from eating those things, had a heart attack. And so, it's not totally safe to eat something as hot as those Carolina Reapers, just to actually eat them. But, we've got some crazy people here in the Carolinas. Most of these are sort of in the South Charlotte area and Rock Hill area. A lot of people that like to try to grow the hottest peppers they can, and they have contests to see who can eat the most and all that kind of thing. I think they're totally nuts myself, but anyway, the pungency or hotness of the peppers are due to the capsaicin content. And if you wanted to calculate the amount of capsaicin in, you take the parts per million times 16, and that gives you the number of Scoville heat units. So it's really a direct relationship between hotness and capsaicin in these red peppers. But it's got a long history of use, both medicinally and as a food. And really what we're going to talk today about, is it really necessary to have very hot peppers to get the results, the medicinal results that people want? And we'll talk some about what some of those are. And there's a lot of things that are attributed as possible results for eating peppers. And some have pretty good documentation, some don't. But Anyway, some of the traditional uses of red pepper, a metabolic booster, that would seem almost obvious, but actually it's pretty well documented for that. Clears congestion, um, improves digestion, it's believed to be a fat burner, lower blood pressure. Boy, I'm not sure about that one. Seems to me like it would almost raise it. But at any rate, that's part of it. Pain relief is a topical thing, and you can buy in Walmart and places capsaicin topical creams and things. Uh, for cancer prevention, I don't know how well that works, but there is some documentation for that, and you'll see that in a minute. Uh, Induces apoptosis. For those who don't know what that is, that kind of goes along with the cancer prevention. Um, when you have a cancerous cell, a cell that's malignant, it's considered referred to often as an immortal cell, and that it doesn't die like most cells do. Most cells are kind of programmed to have a lifespan and to uh, die after that. And you can't keep them in a cell culture for too long because they'll eventually die out. However, uh, people use cancer cells in research a lot because they don't die out, and you can just keep them in culture uh, for many years. I think one cancer cell line, the HeLa ones, um, man, what was her name? Helen Lang, I think the HeLa cells came from, um, are have been cultured, I think, almost 100 years now since she died. Um, so, they can stay around a long time. So, um, inducing apoptosis is one of the ways you might try to deal with cancer, prevent it or cure it. Um, it's heart, cardioprotective, protects the heart. Some people say strengthens blood vessels, clears congestion, detoxifier. This is one of those kind of terms that's hard to really nail down what that means. But ease joint pain, it's an antimicrobial, perhaps, or bacterial growing, from what I can tell. Uh, Improves immunity, helps toothaches, improves skin rashes, provides vitamin A for the eyes, lots of things. So you can find a lot more than that if you go on the internet and start looking. So, almost anything you can imagine has been attributed to red pepper, and it does have a lot of those effects. And red pepper, it's kind of like ginger. It's one of those um, spices that are really potent enough to have functional benefits, medicinal benefits, just as a food, without making them concentrated into extracts. You may want to concentrate them into extracts sometimes because you can uh, get more benefit with less amount of material. But you can really eat enough of ginger and red pepper to get medicinal benefits as compared to something like a lot of herbs, for instance, echinacea or something like that. If you're going to pick echinacea to use it for a medicinal purpose, you would get a whole bunch of it, put a big pot full of it, uh, and cook it down to a decoction, and like that. You could and make a drink out of it or something, but you need a whole lot of it to do that. Um, you don't need so much with something like a red pepper. So you can do a lot more with a lot less uh, of the actual material. Now, there's a perception that the hotter the better. My father had that perception, and he would torment us when we got sick with red pepper teas that were just absolutely awful. And but he thought that was the best thing in the world. And like I said, one person is believed to actually have died from the Carolina Reaper peppers eating them. However, do you really have to set yourself on fire like this to get the benefits from peppers? Uh, and that's kind of an open question still. I'm still wrestling with that a little bit because the research is not really totally clear. It's sort of back and forth on that a little bit. We have capsaicinoids, capsaicin primarily, and capsinoids in peppers. And there's a lot of capsaicinoids other than capsaicin. There's lots of capsinoids other than uh, the capsiate that we'll be talking about. So, there's a number of them, and they have different effects and work in different ways to some extent. And they do a lot of the same things also. But there is some evidence, like I said, that peppers do uh, uh, prevent or have the possibility of preventing or curing cancer. This is from the Journal of Medicinal Food some years ago. Pretty good scientist who's a friend of mine. I haven't seen her in a long time. Rena Yu. Maybe she retired. Seems to be a lot of that going on with people I know. I guess that's has to do with my age. I don't know. I haven't seen her in a while, but she really quite good scientist. And this one, she found that capsaicin induces apoptosis in this cancer cell line by activating PPAR gamma, peroxisome proliferator activator receptor gamma. So that was pretty interesting study. And so what it did is it caused the cancer cells to undergo apoptosis. Now it's important to make a distinction here. And it's done in vitro with cancer cells in a dish. But it's important that it didn't just kill the cancer cells per se. It set back into motion the normal process of normal cell death in there. Now, you could always kill cells with a lot of things, but to make them go through the process of apoptosis, and you can look at the stages of the cell and see when it's doing that. They go through kind of a process that's pretty well characterized. But to cause them to kind of revert to a normal cell type, it's pretty important. So we don't know that it would happen in humans. It's not been shown in people yet. It's a long ways from a cell petri dish to a living human. However, it does suggest at least there's something there worth looking at. I'll put it that way. You always have to be careful in interpreting this kind of data from in vitro data and from animal data, because they often don't work exactly the same in people. And you'll see a lot of times people writing articles and talking about the health benefits of different things. And it's all based on animal or in vitro data with very little human data. So you have to treat those kind of things with caution, because a lot of times they're not going to work the same. But still, it's interesting to know that there is something there worth looking at least. Now, very hot peppers are not necessarily more effective. This is a paper that Sun Min and I worked on some years ago. I think it's been about 16, 17 years. I don't know. This is 2015, not that long. Anyway, it's been a while since we did that paper. But papers with moderate and severe pungency, moderately hot and really hot, prevented memory deficit and hepatic insulin resistance in diabetic rats, induced model of Alzheimer's disease. So that was kind of interesting. It wasn't much difference between the very hot and the not so hot peppers. They both were roughly equally effective. This suggests that burning yourself up with really hot peppers is not perhaps necessary. Uh, and in fact, when I've looked at doses on some of these studies I'm talking about, they sometimes have a low dose and a high dose, and a lot of times there wasn't much difference. Uh, so you may not take as much as you would think to really make it work. Um, this suggests, as well as some of the other things. Um, of course, this is in rats again. Whether it would, help prevent um, diabetes in people, it I mean, diabetes and or Alzheimer's disease in people remains to be confirmed in humans. Um, this is a paper that Sun Min did. I wasn't part of this one, but it was printed in Journal of Nutritional Biochemistry, which is a pretty decent journal. Uh, one by Rena was in the Journal of Medicinal Food, really good journal. Uh, but anyway, I do like the Journal of Medicinal Food. I think it's a great journal, actually. But this one actually found that capsaicin was more effective than capsaicin for diabetes in rats. Now, capsaicin is not hot at all. In fact, you'll find it in bell peppers, in paprika, some of these kind of things. So it's not one that you mind eating, and you can eat lots of. I can sit and eat a whole bell pepper, just chew down it, and it's a good way to get capsaicin. It's not hot to the taste at all, even though it does bind to the TRPV1, which mediates a hot taste. It's not binding quite the same way as the capsaicin is. Dr. Park reported that both capsaicin and capsaicin were equally effective for weight loss in her study, decreased visceral fat, and increased insulin secretion in diabetic rats. However, only capsaicin reversed insulin resistance in the rats, and suggested that if compared to humans, mild peppers may be actually more beneficial for type 2 diabetes, possibly. And if there's anything that I'm saying incorrectly here, you're welcome to jump in, Sun Man. But so that was kind of interesting. To get at least some of these benefits, you don't need the hot pepper at all. The mild peppers are just fine. Now, if you look at the capsaicin and capsaicin, they're almost the same molecule. Chemically, the only difference is this right here. That oxygen there, and probably a lot of you don't understand these diagrams, some of us do, but just to explain it, this is 0 is an oxygen atom, and it's replaced with a nitrogen atom, which has a hydrogen to it. This can form a bond right here. And so this really doesn't. So that's the main difference. You'll see a little bit different in the orientation here, and probably that means that the molecules rotated a little bit. Some people draw this part of it exactly the same. I think this is probably shows more of the rotation of the molecule because of this bond here. And Shingman knows more about this than I do, probably. But at any rate, they're very, very similar, with this being the really key difference right here, the nitrogen there with the hydrogen. However, these small differences can make a big difference in the functionality of molecules sometimes. Now, this study looked at binding efficacy and thermogenic efficiency of pungent and non-pungent analogs of capsaicin. Um, they looked at the anti-obesity effects of capsaicin and capsaicin, as well as the binding of both to TRPV1, uh, the transient receptor protein valenoid 1, uh, using molecular docking studies. Um, I'll talk about, just explain this to the people that don't understand it. I don't understand it as well as Shaman and some men do, but the TRPV1, of course, is the main, is what mediates the hot taste in peppers. When it binds to that, your mouth has lots of them in it. That's why when you put pepper in it and the capsaicin binds to that, it suddenly feels hot in your mouth. Interestingly, there's a lot of those in muscle cells, but they don't of the TRPV1, but they don't transmit a hot feel to them so much, or possibly at all. But what they were wanting to look at is how this TRPV1 binds to capsaicin and capsiate. It turns out that go down here for just a minute. The molecular docking studies, and the capsaicin binds more tightly to TRPV1. The that middle nitrogen we showed a while ago up here, I'll just go back. That right there allows it to bind more tightly into the TRPV1 and kind of holds it there in place, according to this study down here. So it really binds a lot tighter and is longer lasting effect. In fact, the casheate really doesn't have any pungency at all, or any reaction, even though it does bind somewhat to the TRPV1. But both the pungent capsaicin and non-pungent capsaicin were effective for weight loss. But in this study, as opposed to some men's, capsaicin was more effective. So that was an interesting difference, and probably due to the molecular docking. But interestingly, to me, only capsiate was shown to upregulate something called UCP1. Now that's uncoupling protein 1, and that's an interesting observation, because when you look at weight loss, you see this mentioned a lot. You see brown fat mentioned a lot. Brown fat has UCP1 in it, which produces heat, and it kind of wastes in a way, from a metabolic standpoint, it wastes the energy in fats as they're metabolized. So what you have here is a fat burning molecule that doesn't produce energy that'll be utilized otherwise. It's dissipated as heat. And it's kind of one of the holy grails for the weight loss researchers, is how do you get more UCP1 activated in an adult human. Now, mice have brown fat in them, which has a lot of that UCP1 in it, and babies do. As it turns out, animals or people who are very small have a hard time maintaining body weight. So they express UCP1 in brown fat when they're very young, or in mice for their whole life, in order to keep body temperatures up. But as adults get older, they lose the brown fat and the UCP1 because they don't need to, work quite as hard to keep the body temperature up. But they're starting to find little bits of brown fat and UCP1 in people now. They didn't think that adults had it at all, but they do have some, it seems like. But you'll see a lot of studies now for weight loss trying to work on strategies to either produce more brown fat or to have what they call a browning effect of white fat to make it more brown fat like. in order to have an energy wasting system to burn off fat. Uh, and there's been some success, but nothing overwhelming yet. There's not a new major weight loss strategy that uses this yet, but that's on the horizon perhaps. So that was kind of interesting. This paper, a group in Japan showed that capsaicin from sweet peppers uh, can actually induce thermogenesis in humans. So that was kind of interesting. Um, this was shown to probably be due to the capsaicin, since the control was a mild pepper that had neither capsaicin or capsaicin. They found a variety that had neither. Um, they didn't compare this to hot peppers in the study. However, this previous study that we just mentioned found that hot capsaicin uh, did not induce thermogenesis through UCP1, but that capsaicin could do so. And this increased thermogenesis is very likely due to a UCP1 mechanism. So they didn't actually show that in this study, but it would be logical that that's how it's working. It would appear that capsaicin and capsaicin work through some different pathways, and not only TRPV1. Actually, if you remember the first study we showed by Rena Yu, she was that did not appear what she was doing to be working through TRPV1, but activating a different pathway. There's been several studies showing that capsaicin can work through different pathways. That may be one kind of area that's kind of lacking in the cayenne pepper research, is that people really focus so much on TRPV1 that they may have overlooked effects of different pathways in mediating benefits of pepper. So I think that's an open area that needs to be investigated more, because it does seem like some of these things are working in different pathways. So capsaicinoids are better for vascular health, according to this. This one compared capsaicinoids and capsaicinoids. The capsaicinoids, the hot pepper molecules, actually, this was done in hamsters who have a pretty similar way of dealing with fat as humans do. But they found that in hamsters, the hot pepper capsaicinoids lowered cholesterol, reduced the formation of atherosclerotic plaques, and relaxed the aortic artery. Capsaicinoids did most of the same things, but much less so than the capsaicinoids did. If you were going to get a significant effect from it, or a substantial effect, a meaningful effect, you'd probably have to eat a lot more of the pungent, non-pungent peppers to have the same effects on vascular health. Whether you'd ever get there or not, I don't know. But of course, you can. You can eat a lot of sweet peppers, bell peppers without any problem. So it may be that you can get that kind of effect eating the sweet peppers. But really, the hot peppers were much more at the same dose, much more effective for vascular health than was the sweet pepper type products. In this study, capsaicin and capsaicin, hot and not hot active components of the peppers, were equally effective for exercise performance. This was a meta-analysis looking at a number of different studies, and capsaicin, the not hot one, and capsaicin, the hot one, were both effective for muscle endurance, but not clearly effective for endurance exercise, uh, such as running in this meta-analysis. They both increase the number of reps for weightlifting, in other words, in the studies, um, but didn't affect the distance you could run or something like that. Most of these studies used about 12 milligrams of either capsaicin or capsiate. Seems to be what they were using for the exercise studies, pretty much. Almost all of them did in that study. I think there's about 8 studies, and I think all of them had that. Some of them had a lower dose as well, but that would seem to be what people were zooming in on for that. But for endurance exercise, it was sort of inconclusive. So, for this, they seem to be, work about the same. So the long and short of it is, what do you want in a supplement? Do you want the hot stuff or do you want the cold stuff? And that's still an open question because the research is inconsistent and inconclusive on this. Obviously, most people or many people would prefer not to eat really hot peppers. To get that, let's go back up here. To get that 12 milligrams of capsaicin or capsiate, you would have to eat about 500 milligrams. I calculated this out. Probably about 400 milligrams of ghost pepper powder, not something like that, which is pretty hot. Not quite as hot as the Carolina Reaper, but maybe 500 milligrams of a ghost pepper, which is really, really hot pepper. Until they came up with some of these new hybridized things like the Carolina Reaper. That was the hottest pepper out there. It's really hot. Of a more normal but very hot pepper, cayenne type pepper, 1 gram would give you about 12 milligrams of the capsaicin. It's harder to figure it out from hotness because capsaics aren't hot. So you can't make that calculation 16 times parts per million to get a heat index. You can calculate that backwards and get what you're getting from the capsaicin dose. But so, a capsiate is not quite as easy to calculate. But still, that's a reasonable amount, 500, 1,000 milligrams, 1 gram of fairly hot pepper to start your exercise day off with. May not be fun, but you could do it. And it would be apparently beneficial. So, could you do the same thing with the mild peppers? Well, probably. I don't know quite, as far as eating the bell peppers, how many you'd have to eat. That's something that it's going to be a little bit harder for you to determine. It's not really clear in the literature, how much you get and which ones yet that I've found. But the mild peppers do have a fair amount of the capsiate in them. There's still a lot of research that needs to be done. Most of the research has focused on TRPV1 activation by red peppers, and so that's where the greatest amount of research has been. However, which peppers should you sell in a supplement? And I concluded probably both, including making a supplement, a red pepper supplement with paprika and with a hot pepper probably would make a lot of sense. You would cover all your bases there pretty well. And I think that would be the ideal pepper supplement from what I know right now. It's easy enough to get these that are organic and vegetarian capsules. We usually use delayed release capsules for the pepper, so it gets past the stomach and into the intestinal tract before it dissolves, and that keeps it from some people it'll kind of burn their stomach and be a problem. The really hot peppers, so that kind of prevents that. It also prevents the breakdown of the molecules. Actually, it's interesting that capsaicin is not quite as stable as capsaicin is, and it breaks down more easily. And I'm not even sure if the capsaicin itself is what's doing the job a lot of times, because you see a lot of the what they call vanillin alcohols in circulation, but you don't really see much of the capsaicin in circulation. So it may be that some of the degradation products of the, are what's really doing a lot of the work, but we don't really know there. That's more area that requires more study. Right now, we don't have either any of the red peppers in stock. I think we're going to soon. I'm going to change the formula to be a mixture of the hot pepper and the non-hot pepper, and we'll kind of over time maybe fine tune that a bit. But that's what we're doing. We've had a difficult time during COVID of getting capsules, period, and the delayed release capsules were just not available. But the availability of those is improving now. And so I think we'll be back in gear pretty quickly with a red pepper product that it will include this time both hot pepper and the milder, probably paprika or some other one, the capsicum annuum type product. So with that, would anybody like to add anything? Any comments? I know some men's been involved with this quite a bit. I don't know. Have you done any research on capsicums, peppers, Shingman?
No.
You haven't gone that way? Okay.
No. Yeah, only study ginger.
Yeah, I've always thought that ginger and caps and the peppers would make a good combination, maybe for weight loss and some of these things, because they seem complementary to me. But I don't know. I haven't tried it.
Multiple.
I've seen Dr. Jim in the past that, well, I like to say that the delayed release is a good value add for our products, because as a user, I've had products where you can feel the heat in your stomach after you take the product. I don't know if they were using the capsaicin or the capsaicin, but I do know that a lot of times in the fitness realm, it is used as a thermogenic aid, supposedly.
Yeah.
For a pre-workout. And I have seen some results from using products with the capsaicin in it. So it is a good product for fitness and weight loss.
Yeah. It appears to be for weightlifting particularly. They have the one study that I mentioned that it did improve, the number of reps you could do weightlifting. So I thought that was interesting. You have anything you want to add, Sunman? I can't hear you. Your mic's not on.
In Korea, we have different types of pepper, which is making bell pepper and hot pepper. So it has more capsaicin. So it is not that hot, but it has similar functions of pepper. So it is kind of popular for a while, and it is very good for blood glucose lowering effect. So sometimes it called like diabetic pepper or something like that. So you might try some, we call the cucumber pepper. You can try it, and you can use that for making the functional food, I think.
Okay. So you're talking about is it a non-pungent pepper then,
Yeah. So less
or
pungent.
mildly pungent?
Yeah. So
Okay,
it contains more capsaicin. I don't think you can purchase capsaicin, right? When
not
I
easily, no.
That
In
is
fact, one of the studies said they weren't able to purchase it. They had to
right,
synthesize it themselves.
right.
Although
So
I don't know why you can't extract it from peppers.
because
Um,
not much.
not
Usually
enough.
pepper did not containing capsaicin much. So when I study, I got the capsaicin from the Korea Chemical Research Center or something like that. So it is kind of, it needs to be synthesized, but I think you can have some capsaicin from the cucumber pepper, and also maybe bell pepper contains some, I think.
Which kind?
Bell pepper,
Bell peppers, yeah.
paprika.
They're listed as containing it.
Right,
Yeah. I don't know how much. That's the thing. I haven't been able to
right,
haven't, I could not really find that. And I've sort of looked for it, but the actual concentrations of capsaicin foods. Of course, the one you studied was a variety of pepper
right,
by Ajinomoto, which they developed. That's a higher capsaicin pepper. However, they're not selling it. Ajinomoto is only selling it as a finished product. I don't think they're doing. You don't see too much of it out there, so I'm not sure if they're doing much with it. But they've never really put it out on the market much. You can go look for it, search for it on the internet, and find it for sale. But I don't know why they haven't developed it more commercially than they have. But yeah, that's I don't quite understand that.
So
It
it
has
is
a lot of potential, I think.
so cucumber pepper is one of the choice you can use for like.
It has a lot of the capsaicin in it.
Yeah,
I'm not familiar with the cucumber pepper. I'll have to.
right.
Um,
It was popular for like several years ago, I think, but
Okay.
not anymore. But still, some people eat it in Korea.
okay. The one thing about the hot peppers are you've got something. I guess with the non-pungent ones, you don't feel anything when you eat it, like you do with the hot pepper. Maybe that's part of the reason it wasn't as popular. But yeah, it's an interesting product. I'm still trying to figure out exactly how you get, the bell pepper powder. Paprika powder, as I understand, has capsaicin in it, but I don't know. I don't know how much. So still, it's kind of a hard one to really quantify. But also they all have some different capsinoids of some kind in there, and capsaicin and capsaicin are only two of a whole bunch of different. They have a lot of different analogs there, and it's hard to say what they all do. They're not really all characterized too well, and they may well have a lot of benefits there that we and activities we don't even know about yet. So okay, anything else anybody would like to add? Or
So can we get enough capsaicin from pepper that we can receive health benefit, or we have to get it from the supplement?
I think you could get the health benefits from eating peppers if you ate a lot of bell peppers and paprika and things like that, but I'm not sure how much. There again, it's hard to find really good information on that, and it may vary a lot, growth conditions and things like that. So, but with the red peppers and the capsaicin, you know what you're getting in capsaicin based on the hotness of the pepper, pretty much. That's a linear relationship. But you don't have that with the capsiate. You don't have an easy way of knowing, what you've got there, like you do with the capsaicin. So, I think you could get benefit from eating the bell peppers and the not so pungent other peppers, but I can't say that with a great deal of assurance. That's more of an opinion than it is something that's demonstratable, put it that way. But I like to eat non-pungent peppers and put them in foods quite a bit, and a little bit of the pungent peppers too. I like hot foods. So, yeah, and the hot foods and peppers are good for weight loss too. I don't know. Koreans eat a lot of hot food. I don't know if that contributes to a lower body weight in Korea. I don't know. Has anyone done studies on that?
It is kind of difficult to compare other countries, so probably, but I don't think it. Probably people don't, but I don't think it is, because a lot of things are involved in body weight. So
Sure.
I don't think it's just one. Like pepper can affect a lot of effect on body weight. So.
Well, it could be one factor, but it's probably, there are certainly many factors when it comes to body weight, no doubt about it. But that could be one of them, perhaps, because some of the studies did indicate that the capsaicin and capsiate can affect body weight. But how big of an effect is the question. Whether there's a big enough one to really make a huge difference or not. And of course, Mexicans eat a lot of peppers, and they have as much obesity as here in the United States. Some studies have said more, but their average their obesity rate's about the same as the USA and Mexico. So it doesn't. Not enough to prevent it down there. Anyway. Well, I guess we'll wrap it up. I'm glad everybody showed up, and I guess we'll see you again next month.
Bye.
Goodbye.
Bye.
Bye. Thank you, Jim.
Bye.
We'll hopefully have a product soon here.
Okay.
All right, guys.
See you later.